This is Math 2 12.1 notes. That's Math 2, Unit 12, Lesson 1. The title is Circles and Arcs. First thing we're going to talk about is a central angle. A central angle is an angle with the vertex at the center of the circle. And shorthand for circle is just going to be pretty much a circle with a dot. That dot would be the center of the circle. I'll show you a picture of this in just a second. So for now, central angle is an angle with the vertex at the center of the circle. Okay, so let's draw a circle. And I'm going to call this circle P. Circle P means a circle with its center at P. Okay, now I'm going to add more to this picture eventually. For now, I'm just going to draw a line like this and we'll just go all the way through. If a line goes through the center of a circle, if a line goes to the center of a circle and touches both ends like this, it is a diameter. It cuts your circle in half. Okay, I'm going to call this B. I'm going to call this A. And I'm going to draw a line like this. And I'm going to call this C. Okay, so I'm going to label this here 92 degrees. So that angle right here is a central angle. The 92 degrees is a central angle because the vertex of the vertex is at the center, with the vertex at the center of the circle. So the vertex is right here where the two lines meet to make your angle. There's my angle. Okay. All right, so I'm just going to put a little note here that angle BPC is a central angle. There are more central angles in this picture. We're going to talk about it as we go. For now, that we're just going to label that little one. Okay, what is arc measure? Arc measure is, I'm going to say it, then we're going to actually write down what it is. It's the measure of this line or this segment out here. So BC is an arc measure. AC is an arc measure. Okay, so I'm going to write here that arc measure will always be equal to the corresponding central angle. Okay, what does that mean? Angle BPC goes from B to P to C. And the corresponding arc is this arc right here. Kind of like if you took a big slice of pizza, it would be the crust piece here. So the arc measure for BC would equal its corresponding central angle. So this arc measure out here is also 92 degrees. Now I will tell you right now, this unit has a lot of this type of central angle, arc measure. We're eventually going to have inscribed angle, so you want to make sure you get used to the definitions and don't wait until the end. Practice them as you go. Central angle is that angle there. Arc measure is the piece out here like the crust, and it'll always equal its corresponding central angle. All right, before we go through more definitions, just what do we know about a circle? A circle is 360 degrees all the way around. A semicircle is this piece right here, half of a circle, is made with this straight line that's a diameter. So if this is a diameter, this is a straight line, that means this whole angle here is 180. So do we have enough to find that little angle right in there? We do. You would do 180, take away 92. 180 because AB is a straight line, take away 92, it'll give you this angle there, and when you subtract you get 88. So I'm going to mark this here as 88 degrees, which means arc AC, do you see that's the crest for this little corner here, that there will also be 88 degrees. All right, so I'm going to go over notation and how to write that. We would write it like this: MBC with an arc symbol above it equals 92 degrees. That means the measure of arc BC equals 92 degrees. I'm going to put here the measure of arc AC, that's the measure of this one here, equals 88 degrees. Okay, so just getting some notation, symbols, stuff like that out there. All right, minor arc, major arc is what we're going to talk about next. A minor arc. What is a minor arc? It's an arc less than 180. It's an arc less than 180 degrees. And we always symbolize a minor arc with 2 letters. Now, sometimes you may see it with 3 letters, but it's not necessary. 2 letters is enough to talk about and I lied, you're not going to see it with 3 letters. It's going to be 2 letters. 2 letters to represent a minor arc. What is a minor arc in this picture? AC is a minor arc. BC is a minor arc because both of those arcs are less than 180 degrees. So AC is a minor arc, arc BC is a minor arc. Okay, major arc is an arc, obviously opposite of this, it would be an arc more than 180 degrees, greater than 180 degrees. And we will use 3 letters. So, an example of a major arc, there's a few of them in this picture, but I'm going to label one, is ADC. ADC. Now, I did not put a D in there, so I'm going to do that now. I'm going to put it right there. D goes in that picture there. Now, ADC. You pretty much just start at A, go in the direction of letter D, and stop when you get to C. So here's A, go in the direction of D, and go all the way to C. Okay, so I'll mark that one with a pencil. A to D, keep going until you stop at C. Now, can you see that that major arc is definitely going to be bigger than 180? And we use 3 letters. Why 3 letters? Because if I started at A and ended at C, if I just used the 2 letters AC, that would be referring to the minor arc, 88 degrees. So I cannot just call it AC. I'd have to use 3 letters to tell you, hey, you're going in the bigger direction over here to get the major arc. How would you find the measure of arc ADC? What is the measure of arc ADC? How do you find it? Well, we talked earlier, we know this is a straight line, so we know that's 180 degrees. And we went all the way around, so we have 180 plus 92. Now, if you wanted to, you could also say, hey, a complete circle is 360. Take away, 88's the only piece I didn't use, so 360, take away the 88. And either way, you're going to get the same answer. You can test them both. They both end up to be 272. All right, so 2 letters for the minor arc, 3 letters for the major arc. All right, moving along, the next piece we're going to talk about is semicircle. And I already talked about semicircle earlier. It's half of a circle. Now on that one you can use 2 or 3. I'm going to use 3. A, D, B. ADB is a semicircle. Now if they have multiple letters, you will need 3 letters to instruct you on which half of the semicircle. So I would have to use 3 on this one because I have so many letters in my circle. If I didn't, 2 would be enough. ADB, because I'm on the top half, or ACB if I'm on the bottom half. They're both equal. They both equal 180 degrees, but ADB is the top half of the circle and ACB is the bottom half. You could also call it BCA if you wanted to. Okay, moving along. Now, I'm going to warn you right now, we're going to do a lot of drawing on this circle that we're about to draw, and it's going to get pretty messy, so this is not one that you would just hit pause at the end and be able to draw it because it's going to get a little complicated. So you may want to hit pause, rewind if needed. Follow along because it's going to get complicated. Okay, I'm going to draw a center. My center is going to be A. I'm going to draw a diameter. Remember, the diameter goes through the center and touches on both sides of the circle. I'm going to call that diameter B, E. I'm going to draw another diameter here. I'm going to call that one C, F. I'm going to draw a line right here is the most recent one I drew, and you do want them equal, looking equal. I'm going to call this one D. And I'm going to give you some information. I'm going to give you that this here is 130 degrees. That angle there is 130 degrees. I'm also going to give you that this is 50 degrees. And I'm also going to tell you that these two here are equal, congruent. Whew. Okay, what else can we come up with just from this information? I'm going to change now to a pen so I can keep track of what was originally there, what can we figure out. I want to pretty much find out all these little angles so that I can know all the arc measures. Okay, let's see. What do we know? There's a few ways you can think about it. You can think of this as a straight line, and 180 minus 130. You can figure it out that way. Or you can say, hey, these two are vertical angles, so this is 50 degrees because those two are vertical. And double check it. 130 plus 50 is 180, and that is a straight line. Okay, 2 ways to think about this one. I'm going to do the vertical angles again. Can you see that those two are vertical angles? And then take 130 and cut it in half. And you cut it in half because these two are equal. And you can test it. Do 50 plus 65 plus 65 equals 180, just like it should for a straight line. 50, 65, 65 is 180. All right, we are ready now to answer the questions. Now, when you're doing your work, it's going to be like this, where they only give you some numbers and you have to figure out the rest. Find each indicated measure of circle A. A is where the center of the circle is. Okay. Number one, the measure of arc BC. And I'm going to call this whole problem number one, and I'm going to change this to letter A. Okay, the measure of arc BC. Where is BC? This is BC right here. And remember, it's like the crust of the pizza is equal to its corresponding central angle. So it's equal to the 50 degrees in there. So 50 degrees is the answer. Okay, letter B is the measure of arc BCE. Now, I didn't specify in letter A, and I should have. BC, how do I know to go BC this way and not BC the bigger way? Because if they only use 2 letters, it's the minor arc. Now that I'm using 3 letters, BCE, that one's a little tricky because BE is a diameter. So BCE, it's not tricky, it's a semicircle. Can you guys see that? BCE is all the way around here. And because it's a semicircle, it's 180 degrees. Or you could do what I did earlier, 50 plus 65 plus 65. Okay, letter C, the measure of BCF equals. Okay, so there's 3 letters, which means we're going to have to use our major arc, BCF. So instead of going BF this way, we go B to C to F, which is all the way around. I'll mark that one in pencil. B, C, all the way around. You keep going until you get to F. Okay, there's 2 ways of doing that. You can add up all of those angles there. 50 plus 65, I'm going to scooch that over a little bit. 50 plus 65 plus 65 plus 50. Okay, so BCF. So 50 plus 65 plus 65 plus 50. You can plug that in your calculator. 50 plus 65 plus 65 plus 50 equals 230. Or somebody else might say, hey, it's a complete circle minus the 130. 360 minus the 130, and you still end up with 230. Somebody else might say, hey, that's a 180, so I'm just going to do 180 plus 50. However you want to do it, you end up with 230 in the end. Okay, letter D. I want you to find the measure of angle DAF. Okay. So now look at the notation. These are the notation, that's the notation for an arc. Now I'm finding the measure of an angle. But luckily central angles and their corresponding arc measures are equal. Okay, where is DAF? DAF. All right, so this is where it's going to get kind of colorful and a little confusing, so make sure you're following. D to A to F is this angle right here. Can you see that? DAF is going to combine 65 and 50. 65 degrees plus 50 degrees is what you're going to add up. So we end up with 115 degrees. Okay. Letter E, I'm going to squeeze letter E over here. The measure of angle AFE. AFE. Now this is going to get a little confusing, so as I've said before, please, please, please make sure you're following along, rewind if you have to. AFE, so I'm going to trace that. Where's A? A is the center. F, I'm going to go this way. And then over to E. So I'm talking about this angle right here. I'm going to put double angle markings only because I already have one in there. Okay, so this is the angle I'm referring to right here. AFE is this angle. Can everybody see that? Now, I'm going to move this way. Can you see that I have a triangle here? Now this line I just drew in is not part of my angle, but it's part of the triangle. And the reason that's important to know is they're both radii. This is a center to the edge, that's both a radius of the circle, which means that these two lines are congruent. Now we have an isosceles triangle, which means that these two base angles are congruent. I'm going to repeat that because that's the center, and I want the center to the edge, It's a radius, they're both radii. So that means they're congruent, which means it's an isosceles triangle, which means those two base angles are congruent. Whew, that was a lot. Okay, so my work here is going to be the vertex angle, which is 50, plus angle F, plus angle E. I will call those both X for now, just to get the picture in. X plus X, we know that'll equal 180. Why is it going to equal 180? Because the sum of the insides angles of a triangle are 180. So 50 plus 2X equals 180. Hit pause and solve. Subtract, divide, get an answer. Okay, when you are done, you should end up with 65. So X is 65, so X's angle AFE is 65 degrees. They didn't ask for it, but AEF is also 65. So if there's somewhere else they said, hey, what's the measure of this angle over here? It's also 65. Whew. Okay, letter F. The measure of angle FBE. The measure of angle FBE. Okay, so I'm going to trace that one. F to B is right here. Oh, F to B, and then over to E. So it's this angle right here. And I'll use 3 lines this time because I've already used 1 and 2. Okay. Now I know this is getting messy, so this is the angle I'm looking for, pretty much angle B. If I took everything off like here, I'm referring to angle B. Now, I went all the way over to E, but it's not necessary. I could have called that angle FBA, and I'm still referring to the same angle. Whether I call it FBE or FBA, it's still the same angle. Since it's the same angle, I'm going to refer to this triangle because once again I have an isosceles triangle. So I'll call those angles Y, and I have Y plus my vertex angle here, which is 130, equals 180. Whew, that's a lot. Y plus that angle 130 is 180. 2y plus 130 equals 180. Hit pause, solve, and then hit play and see if we end up with the same answer. Okay, you should end up with y equals 25 degrees. All right, that is it for this lesson.